So in today's video, we are going to be looking at trying to increase efficiency by mining with these Bitaxes outside. So we're going to be testing the efficiency of it just normally mining and then the efficiency of it outside. So the reason for this is because we were talking about efficiency the other day, and it might be possible to move a lot of these outside closer to, I guess, a cooler temperature to make them more efficient or kind of force them to be more efficient. And we're going to be doing it with the Bitaxes first, and then we'll make a decision on if we want to move the other Node QXs or the Zybit 8. So I just want to mention as well, you can get, I believe you can get 10% off on power mining for the Node QXs, and then you can get 5% off for the Zybit 8 at Tiny Chip Hub. And I also have a code for, I think, the Avalon Nano, which is MineShop EU. If you spend over 600 euros, you can get 100 euros off. So those all include the Bitaxes, the Node QXs, Zybit 8, and then we have all the Amazon links for a lot of the stuff that we use in the video. So I had a lot of comments asking about, if there's links to all the things that we would use. So thermal paste, Nocta fans, heat sink, stuff like that. The reason that it's on Amazon is because it's easier to get links to compile them all. But anyway, in today's video, we're going to be testing the efficiency. As I said in the previous video on the Bitaxe Hex, we're getting great efficiency on that, about 12 or 11 joules per terahash. And I haven't been able to get down to that with a Bitaxe Gamma yet, at least stable. And I'm wondering if it's maybe because of the core voltage or things like that that are actually limiting us from going to that efficiency. So the main aim of this video is obviously with the fans, they take up a bit of power. So if you can run the fans lower and keep it at a certain degrees, that means that it's going to be more efficient overall, because I believe it's pulling the power draw of the fans plus the actual chip underneath. And hopefully if we can get it to mine outside, then we can decrease the amount of fans or the watts that the fan is pulling and decrease kind of the ambient temperature so it doesn't have to work as hard to get up to that temperature. So we've done a couple of readings, which we'll show you now. Outside, it's around 15 degrees. And then inside, just around here on the table, it's around 21.6. So that's a difference of 6.5 degrees. I know it's not particularly super accurate, but for the purpose of this video, all we needed was a reading of how much the degrees has changed from one thermometer positioned in one place to another thermometer positioned in another place, because it doesn't really matter about the actual temperature differential. We just need to know how much there is a difference on this thermometer. And we could actually do a calculation. I'm not sure how we would calculate it in terms of the differential of the temperature, but how much we actually saved. But we'll see it on the efficiency anyway. And that means that we can basically be more efficient. So we're going to be trying to mine outside just for a little bit. I'll show you the setup now. But let's head over to the computer and we'll show you kind of the control test of what we're getting on both of the gammas that we're currently using. So this one's not turned on and that super is not turned on. And then maybe later on in the video we'll move these two Node QXs outside, and hopefully we'll see an efficiency increase in them as well, because it's basically free efficiency if we do put them outside. We just need to manage things like spiders, which would obviously get all in the electronics and could potentially short circuit some of it, or at least just break little parts of it. If it falls into the heatsink, might heat up, start a fire potentially, but I'm not too worried about that. So let's head over to the computer and we'll show you kind of what results we're getting just inside, and then we'll move it outside and show you the results after. Okay, so here we are on the swarm and we can see the two gammas that we've left on. These are just the other ones. We had the Bitaxe Hex, the Node QX Cyber 8, and the Parasite Node QX. For these two Bitaxes, if we open them up, they're not actually reporting great in terms of the hash rate, which is weird. I'd expect them to be way better. I don't actually know what's going on, but what we're going to do is we're going to reset them to the default. So we're kind of doing a control test. And we're keeping the target temperature at 60 degrees. So for both of them, we're keeping target temperature at 60 degrees. One of them, which is this one, is for the heatsink that is the Copperzilla, and then the other one is the power mining Bitaxe that is newly released. I think they've got a new heatsink coming along very soon, so keep an eye out for that one. I think it's a lot better than the one that they're currently using. But this is basically our control. So we're going to control, see what the efficiency is, see what the temperatures are, note them down, or the power, and then we're going to take it outside and do the same test. So all we're going to do is basically move them outside from where they are right now, because they're sitting next to a window. We're just going to open the window, put them outside, and that should give us the temperature that's outside and the efficiency. So mainly we're going to let this run, get an average figure on both of them. We're going to probably be an hour, and then we'll monitor them when we put them outside to see if there's a drop off or an increase in hash rate. We'll just see. So let's let this run for an hour just on both screens so it can show us the data on here, and then, or at least the average data here, and then we'll put them outside. So as you can see here are the average efficiencies after running for a little bit. We have 16.61 and then 16.37. So those are the average efficiencies. And the next step is to move it outside. So we're going to just record that, but we're also going to, as we move it outside, record both of these screens. So when we're actually moving it outside, we're going to record those screens as well. And then we're going to overlay these on the bottom of the screen so that we can see if either the hash rate goes up, or we could zoom it out a little bit because we need to see the power draw as well on here. So there might be a way that we could actually just show it all without having any of this, or we could potentially just show the power and heat and then scroll it back up to efficiency after the fact. So maybe we should just go with that for now. We'll show the power, the heat, and that gives us an idea of the fan speed, trying to keep it at 60 degrees, and same with this one. And then we'll do kind of a comparison. So we won't be able to see it off the bat, but those are the efficiencies. So it's sitting around 16.5 for both of them. So let's move it outside now, and we'll record both sides of this screen and also moving it outside. So let's move it outside here. So as you can see here, we are currently mining them outside, and that was a bit of a weird janky setup, but it does look like the temperature firstly is coming down, and so is the RPM. So these were about 50 and they've now come down to 28 here. That's 31, and this one's 37. And then the power has also dropped. So I believe that this was around 18, but it's 17.8, and this is 18.4. I obviously wasn't looking at the screen as we were moving them, so you guys can tell me what the actual difference is. We'll go back and look at the actual difference in a minute. But it looks like the efficiency is coming down, so we'll let them run for, I think the average efficiency was 16.5 as we were looking, so we'll let them run for probably around half an hour after this and just see what we can get out of them in terms of the efficiency, power drop, things like that. And this experiment is mainly to show you kind of the difference between mining outside and also for our own kind of research purposes if we want to move them outside, because we do have an option to move it down to the side of the house, which is kind of covered and shaded, so it's not going to rain on it, but it's also outside, so in the nighttime it's going to get a lot cooler and they'll be more efficient, just save us a little bit more on the power or energy side of things. So let's let this run for about half an hour and come back when we see all the results. So as you can see here, after leaving it run, the one with the CopperZilla has actually a worse average efficiency. The power mining one has a better average efficiency. And I'm now wondering, maybe it's because of the fan speed. It can't actually regulate the fan speed on the CopperZilla. So the heatsink is actually doing way more of the work than the fans are, or at least the heatsink and the cold, because that CopperZilla is made from copper, obviously, and the other one I think is aluminium. So it's not dealing very well with trying to regulate the fan speed. If we go down here, you can see that fan speed's at 20 or 30% RPM, which is normally very, very low, and it's not great for the chip because it's not even reaching the target temperature of 60 degrees, if you can see there. Which leads me to believe that the heatsink is doing way more work even in the cold temperature for the CopperZilla, and the actual chip underneath can't even get to the minimum 60 degrees target temperature that we set. So we'll have to leave it run for a little bit more, but that's kind of what I've figured out so far. Okay, so after leaving these for a while, we can see that we had an average efficiency increase in terms of the power mining one, and that is kind of keeping around the 60 degree mark that we see there. A little bit of drop off in power as well, and also the fan speed drop off, obviously equaling a better average efficiency. So I think that that is not trying to counteract the heatsink as much, because the heatsink's not doing as much work. But as you saw in the previous kind of snippet, the one with the CopperZilla actually has a worse average efficiency, and I think it's because it's struggling to actually keep to the 60 degrees, and something's happening within there that basically the fan doesn't need to run to hit 60 degrees, but it needs to be on to actually try and counteract it if it does get too hot, which leads me to believe that the CopperZilla is doing most of the work there, and the internals are trying to manage the fan speed and at least run the chip at 60 degrees. With the power mining one, it might be due to a firmware issue as well, because the firmware isn't as up to date on this one, but it is on this one. So you can see it's still trying to, or struggling to, hit that ASIC temperature. The voltage regulator is actually warmer than the one that the power mining one is using. I don't know why that is, because this is technically a lower ASIC temperature, so you'd think the voltage regulator would be a little bit lower. But both of them are at 60 degrees here, and there's probably a difference of 10 degrees maybe there, maybe 8 degrees. But still, the efficiency is not really giving us a better average on the CopperZilla one. It is technically better on the power mining one, so maybe we just move that one outside, or we look into setting a fan speed for this one. So we could go into settings, and we could set the automatic fan control off and leave it at maybe 20, I want to say. Restart that, and hopefully we can get it up to 60 degrees, and that gives us a better average efficiency, just because the heatsink is doing a lot of the work compared to the one on power mining, and it also may be a firmware mistake that's going on. So we set it at 20%, and I don't think the ASIC temperature can even climb up to that still, but let's let it run for a couple of seconds. Efficiency is really bad right there, and the hash rate is actually pretty bad. ASIC temperature is climbing, so that's good. So this was sitting around 30%, but I'm thinking if we put it at 20%, we can lower it so that the ASIC temperature has time to actually climb upwards. Or maybe it's something to do with the voltage regulator also not interacting the correct way with the chip. But the power mining one seems to be fine. Average efficiency is still considerably lower than the 16.5 that we were looking at, so we're saving around 1 joule per terahash. And it doesn't look like this one wants to hash even at that speed or that fan speed. So it's going past 60 here, 60.4. So I think that that fan speed's a little bit too low. We might need to up it to 26 or maybe 30 and restart it again. We don't want to let it get too hot because we might end up burning out the actual chip underneath. It's kind of dangerous to go above maybe 65, I think. So even here we have the temperature at 59. I'm hoping that doesn't look like it's going to keep climbing. Fan speed at 29%. No, it's dropping down from there. So we may have to do some more counter testing on at least the CopperZilla one. I don't have a clue why the temperature would be, or the efficiency would actually be worse on average than the one before. Maybe it's just that outside the CopperZilla can is taking off heat too quickly for the chip to even get up to higher hash rates. So after testing, I think it's good for the Bitaxe Gamma from power mining, probably not the one for the CopperZilla. So maybe we'll do some testing on the Nerd Q axes and then we'll make an update video of where we've actually put them. But if you guys can let me know in the comments what kind of theories you have for this CopperZilla one, then that would be much appreciated, because it doesn't seem like we can get it to stay stable even outside at lower temperatures. So if you enjoyed the video, make sure you like, check out a bunch of the other videos that are on the channel, and subscribe for more content like this.